now let us see what is an ammeter. It is a device used to measure current and is always connected in series with the element through which current is to be measured. The reading of an ammeter is always lesser than actual current in the circuit. Smaller the resistance of an ammeter, more accurate will be its reading. An ammeter is said to be ideal if its resistance R is 0. Next, conversion of a galvanometer into ammeter. So all of you know basically ammeter and voltmeter are the converted forms of the galvanometer only. And how to convert a galvanometer into ammeter? So here a galvanometer may be converted into an ammeter by connecting a low resistance, which is also called as shunt, in parallel to the galvanometer G as shown in the diagram. So this is the diagram. This is your usual galvanometer, and if you connect a small resistance parallel to it, then it gets converted into an ammeter, or you can use the galvanometer to read the current. Now here, when you connect this small shunt in parallel with the galvanometer, then the equivalent resistance of the combination will become GS upon G plus S. Now here, as G and S are parallel to each other, both of them are going to have equal potential difference, and therefore the current through galvanometer into galvanometer resistance is equal to I minus Ig into S. This gives us the required shunt value, which comes out to be Ig upon I minus Ig into capital G. Now to pass the nth part of main current, that is Ig is equal to I upon N through the galvanometer, the required shunt can be calculated by remembering this very small formula, that is capital S is equal to G upon N minus 1. Now both these expressions will be very helpful to you to solve the problems based on galvanometer and ammeter. So just note them down somewhere so that you will be able to solve them. Now going to the voltmeter. The voltmeter is a device used to measure the potential difference and is always put in parallel with the circuit element across which potential difference is to be measured. So here you can see how a voltmeter is connected. Now this is the battery and this is the voltmeter. So here the voltmeter is always connected across the circuit, or here it is shown to be connected across the resistance. Now the reading of a voltmeter is always lesser than the true value. Greater the resistance of voltmeter, more accurate will be its reading. A voltmeter is said to be ideal if its resistance is infinite, that is, it draws no current from the circuit element for its operation. So remember this fact, so that if some conceptual question arises, then you must be able to answer what is an ideal voltmeter and what is an ideal ammeter. Now how to convert a galvanometer into voltmeter? So as said earlier, a galvanometer may be converted into a voltmeter by connecting a large resistance capital R in series with the galvanometer as shown in the diagram. Now here the current flowing through galvanometer as well as the external resistor R will be same, but it will produce different potential drop across it, and therefore Vg is equal to Ig into G, and here it will be V minus Vg. Now here the equivalent resistance of the combination will become G plus R, and according to the Ohm's law, capital V is equal to Ig into G plus R, which gives us the required series resistance value as capital R equal to V upon Ig minus G, or it is V upon Vg minus 1 into capital G. Now If nth part of applied voltage appears across the galvanometer, then Vg can be written as capital V upon N and required series resistance capital R is equal to N minus 1 times G. So remember these two formula regarding voltmeter and the previous one for the ammeter. Next, you have studied Wheatstone's bridge, so just have a quick look at the Wheatstone's bridge. A Wheatstone bridge is an arrangement of 4 resistances which can be used to measure one of them in terms of the rest. So if you are given any unknown resistance and 3 resistances which are known, then you can find the unknown resistance by putting the balancing condition of Wheatstone's bridge. Now here the arms AB and BD are called as the AB and BC are called as the ratio arms, and arms AC and BD are called as the conjugate arms. Now what is the balanced bridge? Let us see. The bridge is said to be balanced when deflection in galvanometer is 0. That is, no current flows through the galvanometer, or in other words, the potential at point B is equal to potential at point D. Now in this balance condition, what can you write? P upon Q equal to R upon S on mutually changing the position of cell and galvanometer. This condition will not change. So I hope you remember the experiments which you have performed with the help of a Wheatstone's bridge. There you are always asked to take the left gap readings and right gap readings, and then you take the mean of it. And actually we are trying to avoid the contact resistances or any errors which are introduced in the reading due to the contact resistances. So here it is recommended that you should take the readings by changing the position of the unknown resistances. Now what is an unbalanced bridge? If the bridge is not balanced, the current will flow from D to B if Vd is greater than Vb, that is Va minus Vd is less than Va minus Vb, and this gives us P into S greater than R into Q. Now what are applications of Wheatstone's bridge? It is meter bridge, post office box, Carey Foster bridge are instruments based on the principle of Wheatstone bridge, and they are used to measure unknown resistance. Now the meter bridge, as you have used it in the laboratory. In case of meter bridge, the length of wire AC is taken to be 1 meter long. Varying the position of tapping point B, bridge is balanced. If in balanced position of bridge AB, this length is equal to L, then BC, the remaining length comes out to be 100 minus L, and you can write one condition, that is Q upon P is equal to 100 minus L upon L. But we know that P upon Q is equal to R upon S, and therefore S comes out to be 100 minus L upon L into R. Now after the Wheatstone's meter bridge, you have also studied about the potentiometer. Now what is a potentiometer? It is a device which is used to measure the EMF of a given cell and to compare the EMFs of cells. It is also used to measure the internal resistance of a given cell. Now all of you know that the potentiometer consists of a very long resistive wire which can be about 6 to 10 meter long. It is made up of manganese or constantan and a battery of known voltage E and internal resistance R, called supplier battery or the driver cell. Now connection of these two forms primary circuit. So here is the circuit. Now one terminal of another cell whose EMF is to be measured is connected at one end of the main circuit and the other terminal at any point on the resistive wire through a galvanometer G. This forms the secondary circuit. Now other details are as follows. So you have used all these things, and might be by now you must have completed the experiments related with potentiometer. So the diagram must be in front of your eyes. So here this is the primary circuit and this one is the secondary circuit. E is the source battery, and capital E is the cell whose EMF is to be determined, or whose internal resistance is to be determined with the help of all other components. So you have jockey, key, resistance of potentiometer wire termed as capital R, rho as the specific resistance of potentiometer wire, and RH is the variable resistance which controls the current through the wire AB. Now, the specific resistance of potentiometer wire must be high, but its temperature coefficient of resistance alpha must be low. Now, remember this condition whenever you are using any wire as a potentiometer wire, that its specific resistance should be high, but temperature coefficient should be low. Now, all higher potential points, that is terminals of primary and secondary circuits, must be connected together at point A, and all lower potential points must be connected to point B or the jockey. The value of known potential difference must be greater than the value of the unknown potential difference to be measured. The potential gradient must remain constant, and for this the current in the primary circuit must remain constant. And that is why it is advised to not to slide the jockey, but you should tap it on the wire. Now, the diameter of potentiometer wire must be uniform everywhere, and all these precautions which are taken will actually introduce least errors while you are taking the measurements. Now, this is one chapter which you are actually performing as experiments also, so you can visualize what is happening, and therefore very easy to remember also. Now, what do you mean by potential gradient? It is termed or denoted as X, and it is defined as the potential difference or fall in potential per unit length of wire, and denoted by X equal to V upon L. Now, all of you know that V is equal to I into R, and you can write it as E upon R plus RH plus R into R, and therefore X is equal to V upon L, which is equal to I R upon L, or it is I rho upon A, or it is E upon R plus RH plus R into R upon L. Now, potential gradient directly depends on following factors: the resistance per unit length, that is R upon L of potentiometer wire. Second, the EMF of battery in the primary circuit, that is E. The specific resistance of the material of potentiometer wire, that is rho, and the current flowing through potentiometer wire, I. Now, potential gradient indirectly depends upon following factors: the radius of potentiometer wire, so indirectly on area of cross section, and the resistance of rheostat in the primary circuit. So remember these points also, so that you will be able to answer or answer to the problems correctly. Now, the working. Suppose a jockey is made to touch a point Z on wire, then potential difference between points A and Z will be V is equal to X into L. Now, at this length L, two potential difference are obtained. First, V due to battery E, and second, E due to the unknown cell, and that is why if V is greater than E, the current will flow in galvanometer circuit in one direction, and if V is less than E, then current will flow in galvanometer circuit in opposite direction.